Hello dear students, I am Dr. RICHA GUPTA, Assistant Professor at IIIT Delhi, and this video is supported by School Innovation Council, Department of School Education and Literacy, AICTE and MIC in order to foster a culture of innovation, ideation and entrepreneurship. Today we will discuss about PoC and prototyping. Before we jump into what are these terms, I would like to discuss why we need to prototype first. What do we do in an innovation process? First, we look for a problem or opportunity. Then, we try to understand the various aspects of the problem. Then, we explore many solutions. We ideate by challenging the existing. Then, in order to test our solutions and our various ideas, it is ideal to build prototypes. In order to complete the design, build, test, fail, and modify loop. I think it has been a very integral part of innovation that failing and then rebuilding is definitely a part of learning. So, this loop of try, fail, try again, fail again, try again, modify, eventually leading to a successful product is something that we need to foster in innovation. And prototyping is something which can enable us do that. So we can all understand that the first time we may always not succeed. We always may not land on the right answer. So prototyping provides a way to develop, test, and improve our ideas. We can throw away the ones which don't work and then keep trying until we land on the right solution. This has been a very integral part in order to save time as well as money and resources for innovators. It is used across all aspects of design innovation. So, as discussed, prototyping allows to test your ideas before implementing them. It also enables you to communicate the idea more effectively to others. Maybe either we want to collect feedback from prospective users or we want to demonstrate our idea to prospective investors. It encourages reflection, which is a very important aspect of design. You may need to rethink, revisit, reiterate on the problem statements that you might have addressed to begin with. It also helps you answer questions about features, look and feel of your product. It is a low cost and low risk way of testing your ideas. It also helps choosing between alternatives. Because remember, in the ideation phase, we talked about coming up with multiple solutions, but we cannot have many products, right? So which one to take forward? That can be decided based on a prototype as well. So, to summarize, prototyping helps us in the trial and error aspect of innovation. It helps us in developing, testing, and improving an idea. Now, we'll try to understand what are these terms and what do they mean. Starting with what is a PoC? So, PoC is short for proof of concept. Proof of concept is a presentation that demonstrates the technical feasibility of your idea. So basically, it can be a document or a set of documents which try to answer the question whether this idea can work. So in this document, we can try to include maybe existing know-how, initial sketches, or simple paper prototypes in order to prove that, okay, this idea is technically feasible. It may work. Just to give you an example, I'm sure all of you have to go home and do lots of homework every day. And what if you think that, okay, let's build a robot which can do all my homework? What would be a PoC for such an idea? If we can demonstrate that a machine is able to solve a simple problem, it serves as a proof of concept that with additional features, additional technical aspects, it may be able to complete the task at hand. The next logical step after a POC is a prototype. A prototype is something of a model or an artifact that someone can touch, hold, see, or interact with in some way so that they can give us feedback on it. It's more of a first design iteration. Prototypes help us in examining design problems and evaluating the solutions. The purpose of a prototype is to answer some important questions, such as what role does this model play in the user's life? How it should look and feel. Gives us idea about exploring possible materials, possible manufacturing processes, which also determine the look and feel of our product. Also helps you understand how it will be implemented. What kind of expertise or what kind of facilities would be required to manufacture it at scale, for example. A prototype can help you understand that. And as I think discussed earlier, it is an essential part of design thinking process. Now that we have discussed a little bit about both of these terms, it may be a little bit confusing about what is the difference between the two. So let us discuss that. A proof of concept is the first step to moving forward with one of your ideas. The idea of a proof of concept is to just explore and present the technical feasibility and its impact of your idea. However, a prototype is more like a first iteration of the POC. It is like a POC brought to life. And the most important difference between the two would be that a user may not be able to interact with the POC. However, the main purpose of a prototype is that it is something which somebody can touch, feel, interact with, see, explore in order to give us feedback. That is one of the major differences. Just look at an example. So, for example, we look at a problem where the problem statement says that how can you cross a river? So you get an idea that, okay, I will build a boat. A POC may be just able to demonstrate that, okay, a wood float over water, which demonstrate the technical feasibility of something floating over water. And twigs and leaves can act as binding agent or material which can bind many such logs and wood pieces together. That can serve as a purpose for a POC. A prototype, however, is a model where it is able to demonstrate the utility. A user is able to explore its utility, explore its look and feel, and understand and give you feedback. This, even the prototype may not be exactly the same as the final product, which is probably your boat. So the final product may be a boat, it may be a cruise ship or whatever your final product is. But this prototype can be an initial first iteration of your solution. So I hope you get some idea about what is the difference between a POC, proof of concept, versus a prototype. Moving to understand how can we prototype. So there are different methodologies and processes associated with prototyping. We shall discuss the same. The first methodology, which is also very common, is cardboard and or paper prototyping. So the image towards your left is trying to use paper prototypes to explore different forms of a lamp or tabletop artifact. The right image indicates a cardboard prototype of a robotic arm, for example. These are low cost, very flexible materials where you can explore a lot of possibilities. Similarly, these are some more examples of using cardboard or paper to make remote controllers for some purpose. The right image is a very interesting image where there is an entire architectural walkthrough of a bank, for example, where you have tried to create the space itself, where the counters would be, how the customer would interact with different counters, and all of that is done just with cardboard boxes, as you can see. So it provides a lot of flexibility and opportunity to explore various ideas. Other processes may include thermocol modeling. So thermocol also is, I'm sure you are aware, that is a very low cost and easily available material which can be used particularly in cases where there is a three-dimensional form to be explored. For example, you want to restyle a car, or you want to create a, a model which has some volumetric aspect to it, which caters to the utility of the product. So, for example, something which is on the right. So, imagine if you are trying to redesign a mic, or you want to redesign a Bluetooth speaker, all of such products differ largely on the form. Okay? So, some of those things can be explored with such kind of materials. Another material which can afford three-dimensional modeling is clay. So clay is also you can use it in large scale industry. So these images are from uh, clay modeling in the automotive industry, where it is used for styling purposes. But you can also use low cost red clay, which is very easily available, which is called terracotta, which is very easily available in our country in very low cost. That can be also explored. There are also other types of clay which are air drying clay, which are also available. You can explore those materials as well, which is called epoxy clay, which you can find easily in any hardware or general store, generally called M seal, for example, or fevicryl clay. All of these are epoxy clays and they air dry very quickly. You can explore those materials also, particularly when your product involves some three-dimensional form, which you want to demonstrate using a prototype. Then, of course, there is computer aided design, which is using software modeling tools such as SolidWorks, such as SketchUp. All of these tools are available at a low cost, either on browser mode, or you can use it on your computer and create three-dimensional images and models which are down to the concept detailing as per your idea using such applications. You can also render them to look almost realistic, and they can serve the purpose of presentation of your idea, product visualization, and particularly these are very useful when you are presenting ideas to your investors, etc. They're also useful in streamlining working mechanisms and movement. So, such as this is a model of a V engine. Then there are also mechanisms and movements which you can animate in CAD software if your product involves that. Also, a large scale engineering analysis is also possible in optimization. So, for example, a lot of large scale products which it is not possible to build prototypes of the same scale. To take for an example, either cars, or if you want to take an example of a aeroplane. So most of the final detailing, up to the final detailing, the analysis, all of that is done on CAD software, and only the final product is actually made. So it allows for a lot of opportunities, not just to create different kinds of designs and models, but also to test them, analyze them, simulate different environments, and try to understand whether your car model is aerodynamic enough or not, whether so and so pipe is able to bear the load of weight which is it is going to bear or not. All of those testing and analysis is possible. Then there is 3D printing process, which is also now very commonly known. So this allows for very detailed recreation of your models. It can be used in creating different architectural models. It can be used to create different kinds of playthings, and depending on what your idea is. There's also very popular and low cost method which is called laser cutting. This is a flat computer aided cutting of a flatter material like cardboard, thick paper, plywood, or sheet metal, etc. And the cutting is very accurate because it is computer aided. You can create the design on a computer software like Illustrator or Corel Draw, and allow the machine to cut accordingly. You can create 3D assembly of those flat parts. I'm sure you might have come across 3D puzzles which are very easily nowadays available in the market. All of those are made using laser cut, and you can also use this process to create different kinds of prototypes and models of your ideas. You can also create movable assembly of flat parts also, and these are some of the examples of them. You can also create casing of electronic based project ideas. So for example, if there is a chip and there is a sensor which you need to encase, you can create the walls, etc., and then you can assemble it. Similarly, you can use a combination of all of these methods in order to build your prototypes. So, for example, if we look at this image, the track belt is a 3D printed part, the chassis, etc., are laser cut, the front rectangular shape of your robot is also 3D printed. So basically, you can combine such processes in order to make your model and select whatever process is feasible for your idea. And it will also depend on the stage of your design thinking. So if it is an initial level model, probably you can choose a cardboard, etc., cardboard model, or a clay model, which is a low cost material which you can use, mold and cut with your hands. For a next level or second or third iteration of your design, maybe you can move to 3D printing, CAD modeling, or all of these other processes which are mentioned. So, this is where another important term called fidelity comes into picture. So, selecting different methods depends on which stage your idea is at, your which stage of the prototyping or innovation process you are at, who are the stakeholders in that stage. So starting from construction kits like building blocks, etc., up to 3D printing, clay modeling, cardboard, all of these processes can be considered on a spectrum of fidelity. So we'll discuss a little bit about what is the meaning of fidelity. So fidelity refers to how close a prototype is to the final product. There is no single way or right way of choosing a fidelity level. It is entirely based on the goal of the project, the current stage of the project, and the available resources in that stage. And also, who are the stakeholders with whom you want to share the prototype with. So there are generally low fidelity prototype and high fidelity prototype, but there are no binary strict boundaries between the two. As I mentioned in the previous image, it's always on a spectrum, and that is what we will try to understand. So for example, paper, cardboard models, or just sketches can also fall in the category of low fidelity prototypes. So as you can see in the images, if you want to create an application for a smartphone, you can create different screens on a paper, and the outline of the phone is movable just to indicate that uh, different screens are, what is the sequence, what is the workflow. This is a working prototype, but a low fidelity one. Similarly, the cardboard model image which you see on the right is a model of a 3D printer which is made out of cardboard. So you can explore these methods in the initial stage of your prototyping. For a high fidelity prototyping, of course, CAD is there, computer aided design, you can use softwares. In case of an application or a digital product, you can use wireframing tools like Figma, etc., which enable you to build very close look-alike working prototypes of applications without the back-end development done of it, which you can take to the user for evaluation. So, depending on what is the idea, what is the solution, and what is the problem, you can choose the fidelity. And in always in all scenarios, there will be an increasing fidelity level, maybe from the first prototype to the second, third, fourth prototype, there will be an increasing fidelity level. The first prototype may be, rough sketches, or even you can use your toys, which is like a building block, etc., in order to make them, which I'm sure most of you might be having access to. And a higher fidelity prototype in a case of an application may be a look-alike wireframe, which can be made on digital softwares like Illustrator or Figma, etc. In case of a physical product, there can be several methods used. So, for example, if we take an example of this joystick locking mechanism based lock, so the first level prototype can be made using cardboard. Then we can move to a laser cutting model. We can then move to a PLA based 3D printing model. We can then move to a metal based CNC cut model, which is almost similar to the final product, aluminum model. Similar journey I have also went through. So this is an example of a refreshable braille display, which I was part of the design team back in 2014. So I started with drawing some sketches. So the top left, where you see several sketches, are some initial sketches of how the product would look like. Then the bottom left image indicates the CAD model. So this is something which I created using a software called SolidWorks. Then on the top right, you can see the functional prototype journey. So the functional prototype, the step one was to see whether the functionality of braille bits is working or not. Look alike wise, it doesn't look exactly the same, but slowly, after feedback, after 2 or 3, so the third model looks similar to the CAD prototype that I had made. Then we also did all of the component placement. So where will the PCB be, where will the venting systems be, where will the battery be, all of those things you have to plan. And then all of that can also be done using a CAD model, or you can do other kinds of prototyping. And then a final product, for example, the fourth image in the top left image is a prototype which is very close to the final model was created. Similarly, others have gone through similar journeys where they have started with a proof of concept, where they build a chair, which is a medical kind of a chair, using cardboard, and then slowly with every step they evolved the prototype, added various features, added various engineering aspects, added various comfort related aspects, look and feel related aspects, arriving to the pre-production or almost the final prototype. So your idea, your product has also to go through this iteration journey using different prototyping processes in order to arrive at something which is called a final or a pre-production prototype. This is another example which one of our students at IIIT Delhi is working on, where we have created software product which will run on your smartphone, which uses gesture recognition to annotate printed books. So here the participant moves their finger, and the smartphone using their camera reads where the finger is and then gives audio feedback telling that the name of the state, the name of the crops grown in that state, etc. Myanmar, Uttar Pradesh, Rajasthan, Gujarat. The stand and all has been made using laser cutting with wooden ply material. So to summarize, building your idea and testing can help you reach a successful product in a faster and a cheaper way. Proof of concepts are a means to demonstrate the technical feasibility of your idea, answering the important question whether can this idea work. A prototype, on the other hand, demonstrates your ideas working, different features, look and feel of your product. It can also be taken to the user for feedback. Based on the feedback, you can modify your product, you can modify your design, and make a better version of it. As discussed, there are several methods to make a prototype, and there are two kinds of fidelity levels which fall on a spectrum, low and high. You can choose a fidelity level, you can choose materials or processes based on the stage of innovation you are at. So I hope this video on PoC and prototyping was helpful, and it will help you in your own innovation journey to a large extent. Keep at, believe in this loop of try, try again, fail. Eventually, you will definitely arrive at a successful solution. And again, prototyping is an important tool which will help you in reiterating and redoing your ideation and trying and failing and modifying your design in order to arrive at a successful product. I hope this video is helpful in your own innovation journey. Thank you.